Hello, good morning everyone. Here I am going to present about my final project report. So my final project topic is the design and analysis of vehicle to grid and grid to vehicle technology for electrical vehicle. My supervisor name is Ashraf Ali Khan and this is my abstract. The widespread use of electric vehicle has stimulated research into cutting edge technology that maximize the advantages of their connection to the electrical grid. Apart from that, the technologies that enables bidirectional power flow between electrical vehicle and grid, such as a vehicle to grid and grid to vehicle. So basically, the project is on the vehicle to grid and grid to vehicle technology. So especially for the electrical vehicle is designed and analyzing the depth in this project. The integration of charging infrastructure, power electronics, communication protocols, and energy management algorithm is necessary to design a vehicle to grid and grid to vehicle system. The main elements are advanced energy management system, smart grid communication system, and electrical vehicle chargers with the bidirectional power flow capabilities. So we can use for the both purposes vehicle to grid as well as grid to vehicle. Together these parts make it possible for electrical vehicle both charge from the feed power back and when the grid is required then we can send it to be back. Many factors are considered when evaluating the effective advantages of vehicle to grid and grid to vehicle technology. This includes the many parameters on the weather, environment, energy efficient, and grid stability. By using electrical vehicle as a distributed energy resources, grid operations can save money and economic analysis look at the potential revenue stream for electrical vehicle owners throughout the vehicle to grid service. So basically this facility is used to save the money and is economical viable. Bidirectional power flows effects on the grid's voltage regulations, frequency control, and overall power quality are examined as part of the grid stability and reliability analysis by considering losses in power conversion, transmission, and distribution. Energy efficacy analysis examine the effectiveness of power transfer between electrical vehicles and the grid. The environmental impact analysis also considers the decrease in the greenhouse gas emissions brought about the grid integration of the electric vehicle. This analysis looks both the potential reduction in the emission from the electric vehicles, there's the discharging power back into the grid during times of peak demands as well as the emission related to charging to the grid. So vehicle to grid and grid to vehicle both the is a bidirectional parameter we can use as per the requirements. Overall the design and analysis discussed in the project as per the viability advantages and difficulties of using a vehicle to grid and grid to vehicle technology especially for the electrical vehicle. So here the introduction of our project grid to vehicle. It's called G2V is terms that refers to the process of charging an electrical vehicle from power to grid. It is the vice versa of the vehicle to grid, which is the system that electrical vehicle uh, communicate with the public power grid and even provide electricity back to the grid to meet the energy demand and profit the user financially. So by using this vehicle to grid and grid to vehicle, user can only not save the money, but they can also help to protect the environment and we cannot get more pollution. So it is a pollution free. So it is more helpful to implement in a daily basis. Grid to vehicle and vehicle to grid are both examples of vehicle grid integration. So it's basically VGI, which is the integration of electrical vehicle and electrical grids for mutual benefits. This type of technology can help meet clean energy goals such as targeting zero carbon emission by 2045. It can also provide an added benefits to consumers by potentially lowering the cost of electrical vehicle ownership and ownership big surplus power of their vehicle in order to offset the growth of the electric vehicle and the smart grid has creation the vehicle to grid technology. So basically it's not only help to save money and save the environment, but also it's reduce the carbon emissions, and that's the goal is set by 2045. So it is good for the upcoming future. A strong communication and control system that enables effective coordination between the electric vehicles charging infrastructure power grid is necessary for introduction of the vehicle to grid to vehicle technology. The design and study of the vehicle to grid as well as grid to vehicle technology, especially for the electric vehicle, are the main topic of this project. And we already done about the system's technical details, including the analysis and software elements wherever we needed to do implementation. This the V2G and G2 operation. Additionally, we will look at the possible advantages and difficulties of vehicle to grid and grid to vehicle. Apart from that, understanding the complexity of vehicle to grid and grid to vehicle technology will enable the widespread use of the electric vehicles as well as the integration of the renewable source into the electrical grid. A more sustainable and resilient futures may be built by the transport and energy sector, which will also help to reduce the greenhouse gas emissions and carbon footprints. And that's the most important things to improve the energy efficiency. So they can be used in the again and again. Here is the another things. Summary of the design and analysis of the grid to vehicle and vehicle to grid technology for electrical cars is driven in the introduction. It draws attention to the growing interest in the using of bidirectional power flow to connect electric vehicle to the electrical grid. As earlier mentioned, it is a bidirectional thing, so we can do both the things, vehicle to grid as well as grid to vehicle. The significance of the vehicle to grid and grid to vehicle technologies is emphasized in the introduction as well as their potential advantages for the grid and electric vehicle owners. The main topics to be covered in the literature review include the system architectures, power management, demand response, tariff structure, energy management, and system analysis. This sets the stage for the review of the literature. The introduction ends by recognizing the dynamic characteristic topic and the demand for more study in order to difficulties and gaps in existing knowledge. Here is the problem statement. The growing popularity of electric cars, electric vehicles offers a chance to investigate the potential to the technology vehicle to grid and grid to vehicle. But the successfully create and the analysis this technology, a number of the issues must be resolved. So there are lots of challenges still is pending in this technology. So we are mostly focused on to highlight this issue and to resolve that problems. Understanding and overcoming this difficulty is the focus of the problem statement. So there is some problem statements. We mentioned some problem issue which is right now in the market. Technical integration, which is the process of creating a reliable and effective system that permits seamless integration between electric vehicle, charging infrastructure, and the power grid. And there are some little bit issue in the battery degradation. So that also we discuss in this project. To enable the bidirectional electrical flow, this requires creating communication protocol, hardware interference, and control systems. Evolution of the effect of vehicle to grid and grid to vehicle on especially for the grid stability and power quality, potential variations in the power supply, demand and supply, voltage and the voltage regulations, adjusting frequency in order to make sure grid is operating safely and is properly run in the future. Moreover, the selection and development of suitable financial incentives and market mechanism to motivate electric vehicle owners to take part in vehicle to grid and grid to vehicle programs throughout the analysis of the viability of demand response initiative, tariff arrangement, and the payments plan that rewards electric vehicle owners financially and encourage their involvement, analyzing the current regulatory and policy frameworks to spot any stumbling blocks or holes that prevents the widespread adoption of vehicle to grid and grid to vehicle technologies. Examines the requested for grid interconnections law and regulations are offering suggestions create the environment that is the supportive of the adoption of the vehicle to grid and grid to vehicle technology. The potential of electrical vehicles is the value-added grid. There's the transient, resilient, and sustainable energy taking these the technological, government, and economical benefits. Here I am going to discuss about the methodology which is we use in the projects. The essential process is for the carry out the extensive study are outlined in the methodology. Conduct the thorough review of the literature about the vehicle to grid and grid to vehicle technology. And after that we learn about the how this system is actually work, and then we study about the scientific development and industrial challenges, create the theoretical framework about the vehicle to grid as well as grid to vehicle, and then we design about the system, and then we try to implement in the simulations modeling software for the batteries and examine state of the charge management technique, temperature effect, charging and discharging profiles. Consider battery health indicators like capacity, fading and impedance growth, and suggest optimization method to increase the battery life, especially for the electric vehicle where the where only the battery is the heart of the electric vehicle. So we mostly concern about that to validate the suggest the design and evolutions system performance about the simulation and case study. Analyze the technical viability, financial viability, and grid impact of the vehicle to grid and grid to vehicle technology. Describe the result about the design and analysis process about the technical and financial legal implementation about the vehicle to grid and grid to vehicle technology. So these are the user interface, grid stability and reliability, and the comprehensive design framework. So user interface is a user-friendly interface that enables the communications about the energy transaction and between the grid operator and electric vehicle owners. So grid stability mostly these are mostly highlights about the vehicle to grid and grid to vehicle technology about the stability and reliability. The energy efficiency of vehicle to grid and grid to vehicle system is evaluated considering things like power conversion losses, transmission losses, and overall system efficiency. The evaluations aids the streamlining energy transfer produced by reducing energy waste, increasing system overall effectiveness. And after then the we result about the study highlights the technical, economical, environmental benefits of this technology. So this is the widespread adoption of the resilient and the energy future. So here is the block diagram of our system. So basically the grid and grid is connected to the house. So this is the people can use the in about both directional AC to DC and DC to AC. That's the work through the inverter, and here we use the control units. That's the maintain the all the power supply, and Again, the AC and DC is the interlink with the car. So whenever the car requires the electricity, so that time they can use the from the grid, and whenever the extra energy will the store in the electric vehicle, that we can transfer again the grid. So that's the basically the mechanism in the between vehicle to grid and grid to vehicle. Thank you so much. Now the further explanations will do my colleague. Thank you.
I'm Collins. Like my colleague Ashish said, the main aim of this project is to explore and evaluate the implementation and the potential benefits of bidirectional energy flow between electric vehicle and the electric grid. Now, the circle diagram of the V to G and the G to V system involve bidirectional power flow between the electric vehicle and the electric grid. It allows electric vehicles to charge from the grid and discharge stored electricity back to the grid when needed. The circle diagram includes, when you look at this circle diagram here, you see that we have the EV, that's the electric vehicle. This is the actual electric vehicle. It is equipped with a battery pack that stores energy and an onboard charger or inverter that manages the power flow between the battery and the external grid. So it's not connected to the V2G charger. This V2G charger component enables bidirectional power to flow between the electric vehicle and electric grid. It allows the EV, that's electric vehicle, to charge from the grid and also discharge power back to the grid. Now it's now connected to DC to DC converter. This converts the high voltage DC power from the EV battery pack to a lower voltage level, sustainable for onboard electronics and the auxiliary systems within the electric vehicle. We also have our inverter, is connected to the inverter. Now, the inverter converts the DC power from the electric vehicle battery pack or the grid into AC power, which is needed for the operation of various systems within the electric vehicle. So have our power electronics. This includes various electronics components such as switches, rectifiers, controllers, and the filters that control the flow of power between the batteries, inverter, and the grid. It's now connected to the energy management system, EMS. The EMS controls and manages the power flow between the electric vehicle battery, the charging system, and the grid. It ensures efficient and optimized energy utilization while considering factors like battery state of charge, charging or discharging rate, and the grid conditions. We also have our grid connection. This represents the connection point between the electric vehicle charging system and the electric grid. It typically includes components and such as contactors, relays, fuses, and the protection devices to ensure safe and reliable grid integration. Also have our communication interface. This component enables the exchange of information between the EV, that's electric vehicle charging system, and the grid operator. It allows for real-time monitoring, control, and the coordination of the charging or discharging processes. We also have our simulation results. This circuit diagram uses the implementation. This circuit diagram uses to implement V to G and the G to V operation in MATLAB software. There are various output waveforms performed in this study, such as scope output waveform, battery output waveform, DC link voltage output waveform, power output waveform. Now, conclusion. In conclusion, this project has demonstrated the viability and the advantages of bidirectional power flow between electric vehicle and the power grid through the development of a strong V2G and G2V controller and the exploration of various energy storage technologies. The result of the simulations and the analysis shows that V2G and the G2V technology improve grid stability, energy reliability, and the power quality. V2G technology is also a compelling option for a more environmentally friendly transportation and the energy sector because of its positive effects on the environment, including lower greenhouse gas emission. The importance of V2G and the G2V technology in creating a sustainable and effective energy ecosystem is highlighted by this project. It makes a significant contribution to the body of knowledge by advising policymakers, utilities, and stakeholders on how to adopt and support the use of V2G technology and enhancing the transition to a more sustainable and reliable energy future. We also have our references. Thank you.